So this is an interesting problem that I saw the AccuPlacer test give. When is the absolute value of something equal to itself? Well, if you have an inequality, an absolute value, like let's do something, well, let's just do 5x minus 3, but don't make it so complicated it's like that, just make it that it equals 4. Just make up a number for now. So if you have a simpler problem like this, what do? Well, absolute value takes away negatives. So if you have the absolute value of 17, that is just itself 17. If you have the absolute value of negative 17, that is positive 17. So what we basically have to do is say, well, maybe it's positive or maybe it's negative. So if it's positive, you would go 5x minus 3 equals the 4. Or maybe it's the negative case, negative 5x minus 3 is equal to 4. Or what people do is they take that negative and just transfer it to the other side. That way they can just go, okay, there's 5x minus 3 equals positive 4. 5x minus 3 equals negative 4. There, I've got my positive case and negative case. And then just go ahead and do the algebra to solve here. So we've got the same type of situation. We could go the positive case, 5x minus 3 is equal to 5x minus 3. Just keep this thing exactly as it is. Then there's when 5x minus 3 equals the negative case. So with this one right here, in order to solve, we need to put the x's on one side. So subtract 5x from both sides to move it over here. And what's going to happen is these are going to cancel. These are going to cancel. All it says is that negative 3 equals negative 3. But that doesn't tell us what x is. So that didn't really help. Okay, hopefully the next one will. So on the right-hand side, I'm going to go ahead and distribute the negative. So we've got negative 5x plus 3. Then, to get rid of this, we would have to add 5x to both sides, add 5x to both sides. This time it does not cancel. We get 10x. We would need to move the 3 as well, the negative 3. So add 3 to both sides. So it's equal to 6. And then divide. So it's going to be x is 6 gets divided by 10. Or if you reduce that, this could be divided by 2 and this could be divided by 2. So it's going to be 3 over 5. So x equals 3 over 5 is our solution. Now there is a completely different way to do this. So this algebraic way is one way to do it. You can also do it graphically. You could say, okay, the graph of the absolute function is a v. It looks like this. In order to find out where it's going to have this v part, this corner part, which is where it's going to hit the x-axis, what you do is take this thing. So right now I'm only graphing this. So you take what's inside and set it equal to 0. So 5x minus 3, set it equal to 0. Move the 3 to the other side, it becomes a positive 3. Divide, x is 3 over 5. Now, that might be a hint that that's going to be the answer, but look at what's happening is 3 over 5, and then that's where the v is. The corner of the v. It actually is called a corner. Okay, so there's the first graph. Then this graph right here is a line. And the line, again, if you take this and set it equal to 0, that will tell you where it hits the x-axis. And so it's going to be this line right here. So, when are the two equal? Well, if you take a look at the graph, when the two are equal, when does the blue line hit the black V? Well, it happens to be from here to forever. That means that anything to the right of 3 over 5 will make the equation true. So, if for example I pick a number over here like 10, and I check absolute value, 5 times 10 minus 3, absolute value, does that equal, it's a question since I'm checking it, does that equal 5 times 10 and then minus 3? So this would be 50 minus 3 is 47. So does the absolute value of 47 equal, this one would be 50 minus 3 is 47. Does the absolute value of 47 equal 47? Yes, even on Wednesdays, that's true. That means that anything over here to the right of 3/5 is going to make the equation true, which means that if we only did it this algebraic way, we would have missed all these answers to the right. Now, it was this over here that was sort of giving us a hint that, you know what, there's something else going on that you need to check out. This is what it was. That to the right of 3/5, so this actually should have been x is bigger than or equal to 3/5.